Hello there and welcome to this workshop. My name is Valentine and I'll be your instructor. In this course or workshop, we are going to follow this structure. So we'll get started learning about the learning outcomes. After that, we'll go through a section of just learning what are the concepts that we are going to be learning pertaining to Seaborn will be and why we would want to learn about them. Then after, we'll go through a practice session where we go through the same concepts, but now in an implementation approach where we use the Python programming language plus the Seaborn library to be able to implement those concepts that we have talked about. Then towards the very end, we'll just talk about the next steps. So let's get started. By the end of today, we expected to have achieved these learning outcomes. We should be able to demonstrate the ability to create basic plots using Seaborns. That means you should be able to create line plots, scatter plots, heat maps, histograms, and pair plots. And that should open up for the possibility of also creating other visualizations provided by Seaborn. So once you learn how to implement these plots using the Seaborn library, then you should be in a position to be able to transition to working with other statistical visualizations that Seaborn offers. You should also be able to customize those plots. So being able to adjust color palettes, add labels, and grid should also be something that you should be able to do by the end of this course. Lastly, you should also be able to create or use multiple plots. So you should be able to create many plots and have them within one particular container. So you could have subplots which would be all contained within a bigger plot. So the idea here generally is to just help you be able to also communicate using multiple plots all at once. So those are the three learning objectives or learning outcomes that we should be able to have achieved by the end of this particular course or workshop. So starting off, what is Seaborn? Or what is data visualization for healthcare with Seaborn? So this process entails using the Seaborn library in Python to create visual representations of healthcare data. Seaborn specifically, just to demystify a bit more, is a library in Python. Python comes with many libraries suited for different tasks. Seaborn is a data visualization library that allows us to be able to create statistical data visualizations. So if we want to explore maybe patterns within a data set that allow us to understand the relationships maybe between 2 or 3 variables, then we can be able to use something like Seaborn to create those plots. In addition, we can also explore other specific use case plots. Maybe we can create something like a box plot or a violin plot, and these would help us be able to see whether we can find outliers within a variable or column within the data set that we are working with. So Seaborn is more of it's usually recommended that you do learn about Seaborn after you've learned about matplotlib, which is the basic library when it comes to working with Python. A scenario where we might want to use Seaborn is where, say for instance, as healthcare IT professionals, we might be working with hospital resource data, and we would want to analyze the trends within that data to represent maybe factors such as patient admissions, bed occupancy rates, emergency department wait times, etc. The idea would be to optimize resource allocation and also help improve overall patient care efficiency. So that's just the use case. And yeah, so I think once you get to learn about Seaborn, normally when it comes to working on data analysis projects, you should be good to go. So it should be sufficient enough for you to just work on data analysis projects. But at the same time, normally or what sometimes some different projects, data analysis projects, might require you to create interactive visualizations, and that is a task for another visualization library, not really Seaborn. But Seaborn works together generally with the basic data visualization library in Python, which is matplotlib. And it's actually based on matplotlib, and you're going to be seeing us using or referencing, also importing matplotlib to be able to also work with Seaborn. We can also write Seaborn code, but then use matplotlib to style or customize the visualizations that we have. So we could add labels, or we could even just define colors still of our charts, our plots, still using matplotlib while still we are working with Seaborn. They usually come in handy together. So why would we want to perform specifically data visualization with Seaborn over other libraries? It comes with a high-level interface. So this generally just means that you're able to work with functions, Seaborn functions from the library itself, that are much more precise and it's extensive for just creating different kinds of attractive and informative statistical graphics or just visualizations effortlessly. So you'll get to see that you use much more less code than using other tools. Let's say like, matplotlib in some situations to create just a visualization, a good looking visualization. Seaborn also integrates really well with pandas data structures, such as a data frame. So you're able to just pick the data that you have already manipulated using a library like pandas and be able to visualize that data quickly. It also offers aesthetically pleasing default style, so which just means by default, the visualizations that you get are publication ready, so you can just use them out of the box without further customization. We can also use Seaborn, generally just, which is the core reason why we are going to be working with Seaborn anyway. You can use it for just creating statistical data visualizations, not just visualizations, but visualizations that give you just much more information with regards to statistical aspects of a data set. So you can create multiple scatter plots with Seaborn, which usually comes in the form of a pair plot, in order to determine either the distribution of the columns or the variables that you're working within a data set, or even to determine the relationships between the different variables that you have within your data set. So you'll have multiple scatter plots all at once. That's just one example, but there are many, and you could refer to the Python Seaborn or the Seaborn documentation. You could always just Google that to get an idea of the capabilities of Seaborn, because you get extensive support. You'll see that you will get a list of visualizations with regards to statistics that you can be able to create using Seaborn. Moving on, just a few other things, just something to note. These are the different healthcare professionals who might end up using Seaborn, either data scientists, biostatisticians, healthcare data analysts, medical researchers, clinical researchers, healthcare IT professionals working with healthcare data or working within the healthcare context. So yeah, so that's just a quick idea of whom exactly would be directly affected by the use of Seaborn, or who would want to learn Seaborn, how to work with Seaborn. And these are just a few. So at this particular point, I'm going to ask you to visit the resource link that's shared, that we've shared already, that link in the video description of this stream. So if you look at the very bottom of your screen, in the description section, you'll see resources link. Just click on that link and it should redirect you to a page that looks like this. And you can be able to click on the sample practice resource link, this link over here, to get started. It will open what you're going to see, which is a notebook that will contain the content that we are going to be using for practice work for today's course. So click on that link, and you can always pause the video, by the way, if you feel like we are too fast, and then you can resume it when you are ready, once you have already gotten to have done what you're meant to do. Again, you can always rewind if you also feel like I'm too fast. So that's also another option. So yeah, so do that, pause the video, click on that link, and then go to this particular page that I've shown you and click on practice resource. If you want more extensive resources to learn how to work with Seaborn, feel free to become an Afterwork member, and you'll get access to all the challenges for the concepts that we're going to be learning. Like you can see for the sample notebook, we don't have challenges. We have challenges for these concepts, but we don't have challenges for the ones that we have at the very end. So once you become an Afterwork member, you'll be able to get access to all the challenges, as well as a solution notebook that you can use to verify the quality of your solutions, and you can see what is expected of the solutions. So yes, let's do that. Yeah. So once you have it open, once you have the sample notebook, I'm going to be using my practice notebook. I won't use the sample. I'll use the practice notebook. It's still the same as the sample notebook, only that it has more challenges. Once you have gotten to your sample notebook, just click on File, then go save a copy in Drive. Just click on File, save a copy in Drive, and this will save a copy of this notebook to Google Drive. And if you work on challenges and you would want to maybe take a break and come back to those challenges later, then you can still have your work already saved somewhere. But if you just want to explore, you can just work with the notebook as it is. Just know that you won't be able to save your changes. So if you close your browser, you'll have to start from scratch. All right. So once you've saved a copy in Drive, a new notebook will open in a new tab. You can close the original one, which is the master copy. This is the one that I have, and you can now change the name, and also we can get started. So once you have it open, click on Connect on the far end. But before I do that, let me just open mine in playground mode so that I don't have to save any sort of changes that I make to, because it's a master copy. And if I make changes, you will also find those changes after. So once you have done that, the next thing that we need to do is to connect. Click on Connect on the far right. Let me even just zoom in a bit. That's on 25. Yes, so I think this should be better. Click on Connect to connect this notebook to Google servers, which will run the code that we are going to be working with pertaining to Seaborn. So it's going to connect our notebook, and we are good. We are connected. The first thing that we're going to do is now to import the libraries for the work that we are going to do. We'll import pandas to perform data manipulation tasks. And we'll also import Seaborn as well as matplotlib for data visualizations, which are the two libraries. So in any case where you see PD in our code, we are going to be referencing pandas. If we see PLT, we are referencing matplotlib. If you see as SNS, we're going to be referencing Seaborn. Normally these names are usually they're usually aliases. You can think of them as the way people would call other people. Maybe something like a long name like Jefferson might be shortened to Jeff. So in any case, when we are working with any of these libraries, instead of calling or writing the entire name, the entire line over here, we would just use these aliases. So we say pandas pd dot, then the function that library provides that we would want to work with. So all right, so first of all, we're going to go through the first section, then we'll go through the second, and the third, we'll finish off with the third section. So starting off, creating basic plots. So with Seaborn, we can create plots just as with matplotlib, only with a bit of some aesthetics, but also we are able to use less code than with matplotlib, and also we are able to have access to a list of many other data visualization libraries that we would, data visualization tools in respect to statistical data visualizations that we would want to work with. So starting off, I'm going to create, we are going to work towards creating a bar chart, which is just the type of chart that allows us to represent data with rectangular bars, and the length of each bar is usually proportional to the value it represents. So let's first of all load this data set. If you get this prompt, just know that you did not save a copy in Drive. I did not, because I did not want to make any changes. Oh, I forgot. We first of all need to run the prerequisite. So once we've connected, we would need to run the prerequisite, and then later we now need to run the first cell here. So this is the data set that we've imported, and we are going to be importing many data sets. So this is the first one. By the way, if you're not really sure about what's happening here, I won't go so much deeper into it. You can go through the code that we have here, or how to work with the code or the concepts that we have here in another workshop called Data Wrangling with Python, or Data Analysis with Python. Those are workshops that we've hosted in the past, so feel free to have a look at them on our YouTube channel, or even on our website for a structured learning path. So this is the data set that we have. We loaded the data set from this particular location, and it's a CSV data set. So we use the read CSV function from pandas PD, and we stored the outcome in the data variable. Once we store it here, it becomes what is called a data frame. So that's a term that we're going to be using. The data frame, data frame. We display the first 5 records, which are these ones, to understand the structure of the data set. So we have medication and quantity. So what we want is to create a bar chart of medication and quantity. To create our plot, just as before with matplotlib, we can decide to set the size of our plot using the figure function from matplotlib. And then inside it, we pass it this parameter, fig size, which we set it to have this value, which is a tuple or tuple. It's a data structure in Python with 12 units and 6 units. 12 means just across or horizontal on the x-axis, and y-axis we have 6. So these will define just the size of our visualization, and we can play around with them if we feel like we would want to learn a bit more about them. So you can play around with these 2 values. Just change only the values themselves, don't change anything. Then we just reference Seaborn, and we use the bar plot function to specify that we would want to create a bar chart, and we would want the x-axis to have medication, y-axis to have quantity. We can use, by the way, either single or double quotes to reference the data frame. And then we set the data that we want to work with, which is now the data frame that we have here. Then again, we style our plot using matplotlib, where we define that on the x-axis, we want the medication, which will appear on the x-axis, to be rotated, the text to be rotated 45 degrees, maybe because if they were to appear by default as they would, which is usually just listed horizontally, they may not fit and the words may overlap. So we would want to tilt them. By the way, another alternative of that solution of overlapping would be just getting a vertical bar chart, which we could decide to. But yeah, so so we rotate the the medication values. Then here we label our x-axis, our y-axis, and then we add a title to the plot, and then we display the plot. And this is what we have. So it's quite big. So if you wanted to maybe adjust, you could just go to here and say maybe 6x4, and we should be able to see our visualization become a bit smaller. This is what we have, and this might work. And you can also customize font size, etc., using matplotlib. Matplotlib is a prerequisite for this workshop. So yes, you can still go through this workshop without knowledge of matplotlib, but it would be helpful. However, you can still connect the dots if you are able to just follow through the explanations that I would provide, and you could replicate them in the challenges. So at this particular point, I'm going to ask you to pause the video, then work on the challenge that we have provided. Yeah, and then we can continue. Once you're satisfied, we can continue. But if you're an after-work member, you have the pleasure of just going to the solution notebook and checking verifying your answers. Okay, so moving on, line chart. So sometimes you might want to create a type of chart that displays information, maybe as a series of data points over a period of time. So let's have a look at that. We'll first of all load a new data set in the DF data frame. Well, this is our data set. Then what we are going to do is to create the line chart. Here we created a bar plot for a bar chart. Now we're going to use a different Seaborn function called line plot, and we are going to define it twice because we want two lines within our chart, so our visualization. So in a visualization you have plots, which are just visual elements which would be contained within the plot. So here we have the first line plot that we want to define, which would be year versus revenue. Then the second one would be year and expenses. We define the data afterwards. There are other parameters that you could define here, maybe color, etc. To be able to set that, you can drag your mouse on top of the function that you want. Let's say line plot, like I have done. You'll see a pop-up that you see, and you can drag your mouse on top of that pop-up. Sometimes it disappears, sometimes, it stays, but most of the times it stays. Like right now it has stayed. Then you can drop down, like scroll down to parameters, and you can see what those parameters that you can include, and see what values that you might want to add that would help define how your chart looks. This does not look pretty, by the way. You might also sometimes realize that, oh, you want a blue color. An easier way, an alternative, is to use an AI tool like ChatGPT. Just copy this line of code and just say that you want a chart to be your chart to be this color, and it will give you that code that you can later onwards use and replace the existing one with. So so we do that. We also add labels, and labels, those are just we label our X and Y axis, then we add a title and display the line chart. And there we have it. So we now know we can use line plot for line chart and bar plot for bar chart. Those are the main concepts. At this particular point, pause the video, and then when you are done working on the challenge, then we can continue. Moving on, scatter plot. A scatter plot is a type of data visualization that we can use to determine whether there are relationships between two variables. So for example, in our case, we might have a data set that contains age and weight values, which we'll get to see right now. I'm going to run this and import that data. We have actually three variables. We have patient ID, age, and weight, but we might want to determine whether there's any relationship between age and weight. By relationship, we mean that whether the values of one particular variable increase or decrease while the other increases or decreases. So a scatter plot will be able to help us to determine that. So how we do that, we use now a scatter plot function. With the line chart, we use the line plot. With bar chart, we use a bar plot. Scatter plot function. We define the first variable that we want to work with. We set it and set the axis, age, to be on the x-axis, and y and weight to be values to be on the y-axis. Then we define the data, then we display. Here we haven't added a title, but we can. You can just use the same approach as we did here. Add an x label and y label and a title. This is just for quick plotting. We won't get those titles by default, but it's important that we do. All right. Like for example, how to interpret this is that as values of age increase, values of weight increase. So it means that there's a positive, there's a strong positive relationship across the two variables, or with the two variables, or you can also say that those two variables are highly correlated. At this particular point, pause the video, work on the challenge, and then once you're done, we can continue. Moving on, histogram. A histogram is a type of chart that we can use to display the distribution of a variable. So if we wanted to determine how spread the values are within one particular variable, then we can use a histogram. This is maybe, I think it comes from even high school mathematics, where we got to learn about the different curves. You have a bell-shaped curve, you have a curve that is skewed to the right, or positive, skewed to the right, or left, or sometimes positively or negatively skewed. So this is what a histogram allows us to know whether a majority of your points tend towards one particular direction, or of a particular scale that you have for the data that you have, or not, or towards the center, which is usually towards the mean. So let's run this to import the data. So we have age and weight. So with a histogram, we also usually define bins, which will give our hist plot function. So we use a hist plot function to create a histogram. For scatter plot, a scatter plot function. For a line chart, line plot function. For bar chart, bar plot function. So for histogram, hist plot function, we pass the variable that we want to work with. Let me even just remove this. It may not be necessary because we've already imported the data here. And then we just label. Here we're just labeling. Then we just show the visualization. And you can see here that the values tend towards the right side. So this other side. So this might tell you something about the data set that you're working with. Like, the majority of the respondents have weight which tend towards one direction, and you can deduce some other insights of that based on that. All right, at this particular point, pause the video, work on the challenge, and then we can continue. A box plot. So in some situations, we might want to create a visualization that allows us to determine whether there are outliers within our data, so within a specific variable or within multiple variables. In addition to that, we can also get some other statistical information from such kind of a chart. So with a box plot, we can be able to get a minimum value of the minimum value that a variable has, the maximum value. We can get the point at which the first quartile starts or ends. The same case with get the median or the third quartile points, as well as the where it ends as well. So so box plot is something that we can use to just identify whether we have outliers within our data set. Furthermore, we can also use a box plot to understand how spread our data is, and that's also something else we can do. So let's import this data, and we can create a box plot. Now we are going to create a box plot for the entire 3 box plots for the entire data set, and we'll get 3 box plots. So this is what we can be able to see. We have the one for age, heart rate, and blood pressure, and we can see the median values. So the median values are for age, heart, and pressure are the one the lines that you see in between, and you can see that we don't really have outliers. We don't have outliers. We would have points outside the whiskers if we had outliers. So this, we can be able to create multiple box plots for our data set, but we can also create a box plot for just one variable. And how we do that is still we use the box plot function, and then we define the column that we want. Here we defined, we just defined the entire data set, but here we just define just one column. And then we style and display our data and our plot. This is our box plot. Awesome. At this particular point, pause the video and then work on the challenge. Once you're done with the challenge, we can continue. All right, moving on, a pair plot. So we talked about a scatter plot. A scatter plot, the one that we created, was this one. Sometimes you might have multiple variables, numerical variables, and you'd want to visualize all the relationships across all those variables at once. So you could decide to create individual scatter plots, but instead of using that method, you could decide to create what is called a pair plot, which would give you multiple scatter plots. In addition, it would also give you multiple histograms, which would help you also determine the distribution of the variables that you're working with. So first of all, let's load this data set and preview it to understand its structure. And then we can create a pair plot for the numerical variables. Generally, a pair plot will just work for just generally the, would get information, will plot for the numerical variables. So here, as you can see, we have patient ID, gender, patient ID, age, we don't have gender, we don't have blood pressure, which you can still split and get those individual values so that you work with them as well when you're creating, when you're even training, when you're creating a data set that might be helpful later for further analysis. Maybe when you want to create a training data set for a model, machine learning model. So you create a new feature, 2 features from this feature. So there's cholesterol, there's also heart rates, which you see here. But now we have multiple plots. So patient ID, we don't need patient ID. That might not be of that use. So I think I should have excluded patient ID here, but okay, we will do that some other time. So just ignore this line as well as this line because it's plotting, it's giving us plots of patient ID versus other variables, but we can go to age versus, so this is age, this column is age as well. That's why we are getting a histogram. It gives us tells us more about the distribution of data. But age versus this cholesterol, we can see there's a strong positive correlation. The same case with heart rate, this is heart rate, and also this is negative correlation, strong negative correlation with weight. So yeah, this is a better visualization if you want to just view all the information at once and retrieve the actual insights that you need. At this particular point, pause the video. Then when you are done with the challenge, we can continue. Just work on this challenge. All right, the visualization that we are going to finish working on is the heat map. A heat map allows us to visualize data values within a table, which is usually in a matrix format. So we could have a table that has values, and in order to visualize and get much more or better insights, we can use a heat map to visualize now that table. So it makes it easier for us to interpret maybe complex information at a go. So let's first of all load this data set, and once we have loaded it, we have understood how it looks like. The next thing that we can do is to we might not, when we are working with a heat map, we just want to work with numerical values. A pair plot usually excludes the non-numerical variables, but when it comes to working with a heat map, you would need to define numerical variables. So that's what we do here. We just select the numerical column. So any column that has a data type float 64, which is just decimal point values, and int64, which is integer values, we select those variables. So we will end up getting patient ID, age, weight, height. But then we exclude patient ID because we don't have any information, it doesn't give us any meaningful insight. So we just exclude that by having this particular column. We can even remove the comma, not necessarily, but if you leave it there, you won't get an error. So we exclude that patient, so that we are left with age, weight, and height. So let's preview that. Age, weight, and height. So once we have done that, we've manipulated our data and cleaned it. We can now create our plot. So before I even do that, I'm going to do something else. I'm going to print out the matrix or the tabular structure that we would want to visualize the data for. So the core function here, we've applied it to this data frame by putting it .core, and it gives us a matrix that has age, weight, and values, and these values are what are called correlation values. They are more like what we had. So here we had visualizations, but we can represent the strength of the variables using a numerical value. So that's what we are doing here. We are actually calculating those numerical values, the strength of those relationships, and representing them with a numerical value. How we interpret them is usually using a scale where you have -1 on one end and +1 on one end, and the middle you have 0. And if the values of maybe two variables like age and weight is closer to +1, we tend to say that there's a strong positive correlation. If this were to be a negative, then it would be on this other side of the negative sides towards almost the end, and you would say that you have a negative correlation or you have a strong negative correlation. If it's towards the middle, then it means that you have you have no relationships. You have a weak relationship. If you have maybe 0.1, 0.2, or if it's 0, 0, actually, that would mean there is no relationship between those. Those two variables don't have a relationship. So this is what we want to plot and visualize using a heat map. That's why I printed it out here so that you're able to see. That's what we pass here as a first argument to heat map. And then we set annotate to true to be able to provide just more information on the visualization itself. And this is just the CMAP cool warm, the cool warm value. We set it. We set CMAP to cool warm to set the kind of theme or color that we would want to have for this particular data set. And then we just style or add a title and show the data frame. So this is what we are going to get. So the annotate bit, if you do not understand that, annotate just means we want to have these values that you see inside the visualization. So this is a heat map. Instead of a table, which is just numbers, we can be able to see that we have those numbers represented as colors. And you can see that we also have a scale over here from 1 to 0.90. So the color that is closer to 1 tends towards the color red, while the color closer to 0.9 tend towards the blue. It might mean in some situations that if it actually means that the red bit, you can ignore the diagonal red, but these two values have strong positive correlation. Which is actually the same, weight and height. It has a strong positive correlation than height and age. All right, at this particular point, pause the video, work on the challenge, and then we can continue. All right, now we're going to learn how to customize our plots. We won't learn so much about customization. This is something that may take days because the documentation is quite extensive, but we'll cover just some few things that we've even done already, but we'll cover just a few more things that might come in handy in your project. So maybe you might want to customize your visualization using a color palette, which generally would be just a collection of definition of colors that you can be able to use for your visualization. So assuming that we worked with this particular data set and we wanted to create a bar chart, here we define diagnosis and age, which will represent the bars and also the data. but we define the palette to define the palette, which is the collection of colors that we want to work with. We also define hue. Hue just refers to, we would want to have hue as the color for the points that we have, but now they will be represented using diagnosis. You'll get to see that in our chart, and we style and display. Let me see if I can be able to further explain it a bit more. I think that explanation was sufficient enough. By the way, you can't use palette without hue, so you have to set what exactly you would want to have for hue. It just introduces another dimension that you can use for coloring. All right, at this particular point, pause and work on the challenge. Adding labels, I think I've already gone through that process in the examples that we had. So adding labels just involves adding these labels, X and Y labels. Yeah, and also X and Y labels also come with their own parameters like font size, etc. So you could always look towards that. So if you wanted, you could drag your mouse on top of the function that you want to get more information about for styling. And then when you scroll to other parameters, or even just here, you could be able to see, like, label pad means spacing in points. So you can be able to set maybe a numerical value, which is a float, to be able to label. And you can also have the location parameter for that as well. You can set where you want the locations. Do you want it to be on the left, right, etc. Pause the video and work on the challenge. Adding a grid, we can also add a grid to our visualization. So let's create a plot. And a grid generally allows us to visually separate data points. That grid that usually appears in the background. So here we want to, so we are just transforming the insurance coverage in this situation. We just want it to appear in numeric form as opposed to the percentages. So we are just here converting it into a string data type, and then removing the percentage from the string, and then converting it again to a float, so that we just have float values. So here we have now float values, percentages. If we converted this, okay, yes, this is okay. Sometimes you might have 80.01, 0.2. That's why we decided to use a float, so that the original value, this is just the first 5 records. We don't know about the rest of the data set. So the original value can still be retained as a float if it were. So we remove the percentage sign and convert it to numeric, and then we preview, which is what you see here. And then we can create a scatter plot of age versus insurance coverage. And then once we have done that, we can now use a scatter plot. By the way, we set the grid using style. So we define the grid that we want by using the set function and setting its style parameter to white grid. And you could actually get more information, as I had mentioned before, and get more information about this particular function. And then we set it to white grid, and we should be able to get more information about that. There are other values that you could check in the documentation for that, but this is just a way of showing you what kind of grid that you'd want. The rest is just something that we've done before, creating a scatter plot. We've already done the previous one. So this is our scatter plot, and we can also add annotations. So if you also would want to add annotations, you could also consider Matplotlib. You saw the course on Matplotlib, we go through annotations. That's the data visualization for healthcare with Matplotlib course. Right, pause the video and then work on the challenge. All right, lastly, we are going to go through the last concept, creating subplots. We can also create multiple plots and have them within one particular visualization. So if you did not just want to communicate using just one visualization, but you wanted to have multiple of them within, say, one particular, usually called a figure, then we can be able to do that. So let's load this data set. And then we can define how we would want to have those plots come out. So those different plots, those visualizations, we would term them as subplots. And then we define how we would want to have them. So we usually have a grid, which is usually like a figure. It's like, so the grid, the container, the bigger container that contains the plot, we normally term it as a figure. We usually use a figure object. We term it to have a figure object, and a figure object can have multiple subplots. But the subplots, in this case, we give them in Python language axis objects. So we have different axes here. So we say fig wants the figure. We set also the axis. We use subplots. We want to have the grid or the figure to be of 2x2 size, and also we set the fig size, how big we want it to be. Then we use SNS to define and use the histplot function to define the first plot. And then we define here that we want to refer to this histogram should be for this particular axis 0, 0. So that's on the left side. So 2x2, the first plot on the top left, therefore 1, 2, 3, 4. So you have 2 at the top, 2 at the bottom. So the one at the top left is usually has this axis location 0, 0. The one on the right hand side top, it's usually 0, 1. Then 1, 0 is the bottom one on the left, and 1, 1 is the bottom one on the right. So this is what we do for the different visualizations. We create histograms, and we use the locations for defining those locations of the subplots. We use set title to set the title of those histograms. And also here we are setting the layout of, the appearance of the ticks, like the way we defined earlier onwards here in our bar chart. We defined we wanted to have the X ticks rotation as 45. Here we would define that same situation by using same thing. We define the same thing by using tick params function, specifying which axis values that we would want to rotate, and then we define the rotation. We do that for these two values because the values tend to overlap. And that's it. We just style and display the plot, the entire plot itself. So you have a bigger plot, but that contains now multiple subplots. The PLT reference here just applies to the bigger plot. But if you want to specifically refer to the individual plots, you use axis, then the location themselves. Tight layout just defines that we want to have just a compact visualization. And there you have it. And the reason we are getting a grid here is because we had defined a grid here. So we could always set this to something else. So anything that comes after that will be applied to that other grid. So, all right, at this particular point, pause the video, work on the challenge, and then we can wrap up the session. All right, so that's it. That's it for this workshop on Seaborn. We hope you are able to get the basics of Seaborn. What we have covered will help you to further work on other types of visualization using visualizations of plots, implementing them using Seaborn. So just visit the Seaborn documentation by just clicking on, or just going to Google and just searching Seaborn documentation and exploring. You'll realize the implementation is quite easy, having gone through this particular course. The next step, normally we recommend working on a project so that you can put into practice what you have covered. We have a Seaborn project. If you go to our website, and if you're an Afterwork member, you can go to the data visualization with Seaborn course, the one that doesn't have any context with healthcare, not the one with healthcare, but the one that is just data visualization with Seaborn. And then you can be able to work on that project. And there's also a project solution that will just help you to just verify to what extent you are able to apply what was required. It's going to give you a real world challenge. And if you're looking towards learning something next, our recommendation is now to learn about interactive visualizations, because a prerequisite for this course was Matplotlib, the basic visualization library in Python, then Seaborn for creating advanced statistical visualizations, and then now for interactive visualizations, we would recommend Plotly or Bouquet. Would recommend Plotly because it's also not as difficult to implement, but still either of the two would work, Bouquet or Plotly, but Plotly is what we usually recommend. Not necessarily, Plotly comes in two different styles in terms of approaches when you're creating visualizations, interactive visualizations with Plotly. There's the one that use the PyExpress module and the one that use Go objects. We would recommend, first of all, going through the PyExpress one, which is what we are going to be working with next. It's lined up for streaming is the next workshop. So feel free to also sign up for that workshop, or even if it has already happened, you can always just check on that workshop or course on our Afterwork platform. All right. I hope you're able to learn a lot in this workshop, and we hope that you're going to put into practice what you have learned in your practice in your day-to-day work. And if you loved the experience, be sure to give this video a thumbs up so that other people who are like you would be recommended. And also, if you would want to be informed of future posts of such courses, be sure to subscribe to this YouTube channel, and see you in the next video, in the next course. Bye bye.